My top boss, welcome to this live stream where we are talking about electrical troubleshooting. Our main focus is definitely on the domestic electrical installation. When it comes to troubleshooting, especially using a multimeter, we have a lot of malfunctions that may occur on this specific point here. This is referred to as a consumer unit. In a consumer unit, we have very important features. First of all, we have that which is the neutral bar or the neutral connection. What are some of the faults that are associated with loose connections on the neutral bar? We'll talk about that. But first of all, when it comes to MCBs, protective devices that we have. For instance, this one, we have an SPD, surge protective device. We have the isolator, we also have the RCCB and the MCBs. Loose connections are the main issue that can occur in these MCCB or MCB connections here. As you can see, there are multiple connections. These connections serve various circuits, like we have here the cooker. Assuming that the cooker is not receiving sufficient power, there's going to be a problem. Sometimes you'll find that this light here is dim or really flickering, that you can see it with naked eyes. Same as this one for an instant shower heads. This is a heater. Heating circuits face a lot of issues, especially if the installation was not done by a qualified person or a careful person who was definitely concerned about tight electrical connections. When it comes to lighting, look at the switch that activates a light or a lighting circuit. You'll find that you only have one gun activating multiple circuits, and therefore, according to me, to find issues with loose connections, especially the lighting, is sometimes very rare. But if it occurs, you find that it is in the fixtures, the bulb holders, or at the connection where you have that lighting, probably the switches, or if there's a loose connection at the JB junction box right there, or any looping or termination box, right? So you're going to talk about that, especially at the meter box. There's a loose connection, definitely you are going to have it rough. Top boss, let me know, where are you streaming from? Are you ready for our today's live stream, our today's session? If my top boss, you are encountering this channel for the first time, kindly smash that subscribe button so that you may continue to learn more when it comes to this topic, if at all this is your interest. My greatest focus is usually the beginner electricians. Andrew Regan, good to see you. Say always educative info. Thanks, Mwalimu. Thank you too, Regan. Means a lot. Now, what are some of the tools or equipment that we normally go with when it comes to troubleshooting? If you are like most electricians, you'll find that what they will have with them is a simple tester, a pliers, and definitely a screwdriver. I used to be that way as well. You have been called to go and carry out a troubleshooting issue somewhere, and you really underestimate the problem. You are like, I will not have any challenge. So you just go with the bare minimum, right? Bare minimum referring to a simple tool like this one, a tester, right? You go with the pliers. All right, a pliers is meant to fix. Let's say you encounter a loose connection and you're supposed to fit. Another thing that people commonly have with them, especially if they're beginner electricians, is an insulating tape. But now my top boss, today we want to talk about another level that you can get as an electrical technician. One of the problems that may occur when it comes to this electrical installation is loose connection. Now, at this point, let's start here. At the meter box or the meter board, you have an MCCB. What does an MCCB stand for in full? What is the difference between an MCB and an MCC? My top boss, this is a very interesting session. I love it. I couldn't wait to start it. It's been a long time since I actually made it come to life, because I've been looking forward, to have these sessions when it comes to troubleshooting. Now, briefly, let me just explain what is on my board, my top boss, if you don't mind. What is coming in here is the mains. Assuming that this is a drop from the national grid, the drop cable, it gets to our meter board or our meter box. Thank you so much for the likes. I see them coming in. It means a lot when you are not only watching my content, but you are participating by either smashing that like button. And if you have not subscribed, you subscribe. It means a lot. Most of my top bosses interact with me on my comment section. I love reading your comments and especially replying to them, because that is how I interact with you and I know what you are thinking. As the captain of this ship, I want to know what my crew is talking about. I want to also know the people that I have in my ship. What are they thinking about? What keeps them awake at night? What bothers them? All right, my top boss. So today in our live TikTok show, we discussed about the issues or the challenges that electricians go through, and we were able to find that there are customers who do not pay when they are supposed to pay after you have worked for them, and that is very unfortunate. Other customers actually refuse to pick calls whenever an electrician is following up on a pay. What an unfortunate incident. I passed through that in a couple of months, and even last month I experienced that. I went and sorted a customer's issue only for them to promise me that they will pay. In fact, I supplied even products from my own money, and my top boss, let me tell you, it is so painful that right now they are not picking my calls, and I've been trying to follow up on the money that remained. They are not paying. Other electricians were confessing that they are facing the same challenges, and this is very, very bad. No one prepared us for this, my top boss. And listen to this, there are other electrical engineers or contractors that have been in the field for the longest, and they understand how we struggle as electricians, and they also pass electricians through the same. It is very, very bad. Juma Yoweri says, I have really learned a lot through your teaching. Thank you. God bless you. Thank you. Thank you so much, Juma. Means a lot. Now, when it comes to this, we have an MCCB that is right here. This acts as the main switch or the isolator. It is at the meter box simply because it is supposed to isolate the entire installation. Now, when you have visited a customer and there is a problem in the house, let's say there is a very big issue, maybe even fire, this is the safest point for you to isolate electricity. Let us isolate electricity in case there is flooding, there is fire, so that we can deal with other issues. In fact, when it comes to quenching that fire or putting off or putting out the fire, it is advisable for you to ensure that there is no current flowing in there, because if at all you are supposed to use like, let's say, liquids which may conduct electricity or pose as electrocution agents to that customer or that person, then it means that electricity has to be off, right? So that is that. At the meter, we also have our meter, and then from there we have these cables flowing all the way to the consumer unit. Like I've always said, or like it is always is, that electricity flows in a loop. So even if you see all these gadgets here, it is a simple loop that has all of those devices. Assuming that this is the loop from the starting point, assuming it is on top here, the transformer coming all the way to the meter box, the consumer unit, everything, it has to go back. So everything that you place inside of that loop is very, very intentional. An MCB to a specific circuit, let's say it is lighting circuit, is placed there specifically to shut off that supply of current in that circuit, the lighting circuit, if at all there is an issue on that circuit. All right, so let's say we have an issue here. This bulb is not turning on, and yet at this point here in the consumer unit, you find that this MCB has tripped. Where do you start? Now this is where the juice is. A customer has called you, they have told you, my lights are not working, be it in the bedroom, the sitting room, a section, they are not working. All right, then if you are smart enough, you ask the person, is the TV on? Is the fridge, the microwave in the kitchen on? Are all the sockets powering on? They say yes. All right. Now what you need to do there, my top boss, is simple. You need to check where the problem could be. All right, just in a few, let me connect something. So electrical troubleshooting is not that complicated as many may think. It isn't, my top boss. Absolutely, it is not that complicated. And we are going to find out that most of the people who have issues when it comes to finding out where the problem is don't have the basics that we as electrical technicians are supposed to be having. Okay, so if you are struggling with the basics, then it means that electrical troubleshooting will really disturb you. You will have a huge challenge. Power is flowing in here, light is on, the customer has called you, they have told you that light is off. I've been trying to switch on, nothing is working. Do you go ahead? Because at this point you have to suspect that there is something that has tripped, and true to your suspicions, there is an MCB that is down right there. Again, remember, in a house, especially these big houses, you'll find that there are several circuits in there. There is a circuit that is supplying the security lights and the common area sections. A smart electrician will ensure that that one is a single circuit which is supplied or served with one MCB, isn't it? And then you have the sitting room and probably two bedrooms, two of the many bedrooms that you have. And then you might have, like, let's say the corridor and, like, let's say the dining. Okay, so you don't connect all the circuits to one MCB, because if at all that MCB has an issue, has tripped, let's say it has tripped because of its own wear and tear, all right? Due to time, due to use, an MCB might fail to perform its duties. So what happens in that scenario? That MCB will trip. But now, my top boss, we don't want to shut down the whole lighting in that home. How do we ensure that? We ensure that we come up with several circuits. We can even come up with 3 circuits. A circuit that activates the security lights and the lightings in the common areas. Another circuit which activates some parts in the home. Okay, let's say in the dining room, let's say the kitchen and the corridor. Another one, it's the bedroom or bedrooms as well as the sitting room. Why should we do this, top boss? It gets very interesting, because you don't want the customer to have total darkness, even though they may be having television, they may be enjoying Wi-Fi, but they're in total darkness. That is completely out of order. I have my top boss, Elfas Kimugor. Thank you so much for joining in, saying, good work, teacher. I am enjoying today's lesson at Mugunya area, Nanti County. You are very much welcome, my top boss. I have another top boss, Fidel Castro. Good to see you once again. You were here yesterday. Say, kindly, can you finalize on inverter connection from the national grid, please? Of course, I will do that, Fidel. Thanks for reminding me. Elfas is in the building. Okay, I've read that one. And Macharia Njeru, good to see you, Macharia Modoanyoba. Welcome. You are saying this. A pleasure to learn through your live lesson, Mwalimu. Kudos. Thank you so much. I have I'm a neuter. God's way. Hey, wow, what a name. Says, I'm really enjoying your beautiful teachings from Ghana. Thank you. Ghana is in the building. Kenya is in the house. And I really do appreciate you so much. Thank you so much. So let us clear that out. One MCB is down. All right. So you will ask your customer, yes, there are no lights. Which one specifically? Maybe they will tell you the security lights are not working. Now, if the entire lights in the home are working apart from the security lights, then it may be or may not be an emergency, because they are not in total darkness. That means that the electrical installation that was done was great. Now, you only have to go and sort out the issue of the security, my top boss. All right. So that MCB is the one that you go and sort out. So, like, for instance, here, I don't know whether I can get the camera closer so that you can be able to see, right? So I have a 6 MCB, 16 MCB, and a 20. So you can have those as dedicated circuits, my top boss, right? So dedicated circuits, in short, I mean that you have several circuits several MCBs for several circuits, and you simply have to justify No, everything. Somebody told me it's about justification, right? Sorry about that. 3-2 mic check. Am I audible? My top boss. So this breaker is down. There is no light. You will ask your customer, probably, is there any circuit breaker that is down? Just fix my audio here. Apologize for that. Or you will find a scenario like what I experienced. The customer says that they don't know what a CCU is, consumer unit. They don't know that customer consumer unit. All right. So they and even if they know, you tell them there is a box around the corridor or the kitchen. I don't know where you top bosses place the consumer unit between the corridor and the kitchen and the dining room and the sitting room and the bedroom or even the bathroom. Which is the best place for you to place a consumer unit? What dictates where the consumer unit will be installed, or what informs your decision on where to install a consumer unit, my top boss? Yeah, Achari Anjero says, yes, I am audible. Thank you so much for that. It means a lot to me when you confirm that I'm okay. Might be talking to myself here the whole day. This heater here is powered on. You can see that light. I don't know whether you can see it. It is on. This cooker socket here, or the cooker unit, is on, but the light here is not turning on. Those are some of the very important questions that you ask your customer. So the MCB is down. Now, once you visit the customer, you have seen that the MCB has tripped. You start troubleshooting. All right. Now, here is where this important instrument comes in, the multimeter. Digital multimeter. On our yesterday's live stream, we were able to talk much more regarding a digital multimeter. In fact, yesterday we covered much to do with continuity test. We agreed that continuity test is whereby you bring these probes together and then you will hear that beeping sound, and it will shift from a 1 to 0. What does that mean? From infinity to continuity. Is that a little bit challenging for you, my top boss? It means that it is measuring infinity. That is why you have one. Infinity. There is no flow of charges in that medium or media. But again, if you bring them together like that, there is that. You can hear that. I want to thank you so much, my top bosses. I can see constant likes coming from you, my top bosses. It means a lot. It really means that we are together and you appreciate the work that I'm doing. That's the best that you can do. I appreciate that. Now, if I take a cable here, if I take a cable and then use that to demonstrate continuity, right? How will that turn out? We are also going to talk about sizes of cables and their purpose and why use a specific, because in this live stream we are going to learn a lot. We are not going to, cherry pick. Simply because we have said that we are talking about troubleshooting using a digital multimeter does not mean that we'll stick to that. You can even have as many questions as possible, my top boss, and I'll be reviewing them. So this is a cable. We want to test for continuity. Is it broken? Can it allow the flow of electricity? I say the flow of electricity or the flow of current. You hear that sound? My top boss has said, how can I use the multimeter to check the voltage, the earth and neutral in the consumer unit? We are going to that right now. Frank Edward Bahati, what a great name. Good to see you. You're saying I learned much through you, top boss. Thank you so much, Frank. Welcome, welcome, welcome. This is a good question from our top boss, Aminuta. Says, how can I use the multimeter to check the voltage, the earth and neutral in the consumer unit right now? Right now. So this is what we are going to do. We have learned about the continuity test. If you want to learn more about the continuity test, kindly the video that I did yesterday, our previous live stream, you will learn a lot. So we want to test for voltage. When it comes to voltage, my top boss, we are talking about AC. So where do you see this pointer here, or can we say the knob? What can we talk about it? You see this circular knob here. There are so many calibrations here. Should I say calibrations or vices or quantities that we can record with this digital multimeter here? Okay, so This blue that you can see here is resistance. Resistance, and record resistance of a wire. Mostly it will find application with even the electronics engineers, those people who are also dealing with instrumentation. Very tough topics right there. I mean courses. We also have current, and this is AC current. You see, when you see A and then that wave, it definitely means alternating current. You're measuring alternating current in terms of amperes. So here is amperes, 200 milliamperes, 20 milliamp, and so on and so forth. At this point here where we have white, we have direct current. You're recording direct current. And first of all, if you want to use a multimeter, you have to know that you will have to isolate that circuit. I hope we know that, because you have to place the digital multimeter in series with that circuit. So let's say you have power or current flowing through a bulb from a battery. So you will simply cut that wire or disconnect it and place your probes in series so that you can record the current. Okay, when it comes to this blue on this part here, this is the capacitance. Also finds a lot of application with our top bosses in electronics instrumentations as well. And you place your capacitors here so that you can record capacitance. You see here, so you not be using the probes, all right? So you must be able to know properly the use of a multimeter, otherwise you will blow it up. This point here records what we refer to as a diode, again for our top bosses or our brothers and sisters in electronics engineering. This yellow that you can see here is definitely, first of all, for CX or capacitance, you will have to turn it up to this point. When it comes to the diode, you turn it to that point, all right? Now, when it comes to voltage, direct current voltage, DC, you place it here. So all this white that you can see here, the V, the line and the dots, that is direct current or direct voltage, DC. So you place it here, assuming that we want to take the readings of the voltage of this battery. Is it a battery or is it a cell? Everready is such a great product. So we will simply, in fact, for this one, again, when it comes to taking readings from a digital multimeter, you really need to understand what you are expecting or what you are recording. So for this one, how many volts is this? And is it AC or is it DC? Albert Domenio says it's a cell. Incredible. So my top boss, how many volts are we expecting from this? Albert is very proactive, says dry cell. Absolutely. How many voltage? How many volts do we expect? Is it DC or is it AC? So that we know what to record with our digital multimeter. Juma Yoweri, good to see you. Very proactive here, not just warming our seat here at Top Bosses. Van, you are saying 1.5 volts. Is it AC or DC? What a lame question that is, John. Come on. Come on. But anyway, I just want to know whether we are together. Is it AC or is it DC? 1.5 volts from this one, this battery. DC! Juma Yoeri, you are those students that the teacher used to say, no. You have answered too many questions. Let us hear from someone else. Thank you so much, Juma. Machari Anjeru, what is the answer? DC. Absolutely. Thank you so much, Macharia. I also have Frank Edward Bahati says it is DC. That is incredible. Now, we will place our probe at this point. We have positive terminal here and we have negative on this other side. This is where I started as a kid. I really understood about these batteries a lot. I mean the cells, because whenever I used to interchange the terminals, I would be faced with a lot of issues. Now, your volt, you see where you place before you record the readings. You see where I've placed it on 2, at 2, because I expect 2.5, I mean 1.5. If I place it at 20, that is too much. That is like taking a reading from a 12 volts battery or a 19.5 volts battery. When it comes to, like, let's say a laptop adapter, it gives a 19.5. I place it on the bottom. Frank Edward Bahati says it is DC. It is 1.5 volts DC. Incredible. So that is what we have. 1.486. If we round it off, definitely that is 1.5 volts in DC. What happens if you are recording, taking the reading at AC? What will happen? at AC. Do we still get a reading? So I place the probe right there. No, it's good to test, but there are some cases where you are not supposed to risk. It's like risking a multimeter. Recording for at the AC, what do we get? Nothing. I know that is so lame, but just stick with me. So everything on this multimeter here is very intentional. It is not just placed there for the sake of it. So that is what we have. So you must ensure that you understand correctly what you are recording. When it gets to AC, like our top boss had requested to record the readings, we also set it at 750 because we expect a reading of over 240. The closest to that is 200. I will damage my digital multimeter, so I place it at 750. So if I get anything between 200 and 200 and 749 volts, that is okay. My digital multimeter will not be damaged. Now we come to this board. Let me just get my camera closer, right? So that we can be able to record our readings. We're starting the voltage as requested by our top boss. So I'll ensure that my digital multimeter is set right there. Okay, very, very important. Having it set at that point, what do we expect and where? We expect 240 volts. We expect between 220 to 250 volts or thereabout. Ryan Onyango says, I feel like CCU should be best placed in the house corridors or walkways for better circulation of air and temperatures. Top boss, incredible. Common areas, isn't it? Right, incredible. We have our digital multimeter set. We want to record the voltages that are coming in. We will start at the meter box. At the meter box, we place our probes like so. 230, it is constant. Very good. 234 volts AC. When you remove the probes, it gets back to 0. On this other side as well, you get 237. Where is the difference coming from? It's just right there. So between the phase and the neutral in terms of voltage at the consumer unit, 236, that is okay. We have these MCB that are stripped. What could be the cause? What is the problem? But again, as my top boss wanted me to do, is to simply record between the phase and the neutral. Phase and the neutral voltage we get is 235, as we have rightly seen right there, my top boss. Okay, so that is between the phase and the neutral. Now, when we want to know between their voltage, between, is there a point of taking the readings between neutral and the earth connection? One of the things that we need to record there is continuity test. They should not be continuing, and I'm going to explain in a while. So we take the probe to, I mean not the probe, the indicator or the pointer all the way to continuity, so that we can record between the neutral and the earth connection. So there's no continuity. So this is the reason why there should be no continuity between the neutral and the earth connection. Why? Because we have this important device here. What is the name given to this device that I've just switched off? When you switch this device off, everything is shut off. And we can prove that using our tester here. So if I place a tester on these, you can see that they are indicating this tester working really. Just see, did it burn? Now there's another fault that I want us to sort, by the way, that I have localized here, that I have come up with. If you place a tester on the live or the face or the line and the tester is not turning on, but when you place the tester on the neutral, you have the tester turning on, what could be the problem? Let's address that. Okay, so what are some of the issues associated with that? Top boss, we have taken the readings, and in fact, when you use so before taking the readings, all right, before taking the readings, ensure that the multimeter is well placed, because I was testing for AC voltage while I have placed it at the continuity. That is why I almost damaged my digital multimeter. So you have to be very careful not to do such a mistake, my top boss. Now, what I was saying is, you have a digital multimeter set to AC. We expect a reading more than 200 volts AC. So we will not place it at 200 volts, even though you were expecting exactly 200 volts. For instance, when taking a reading for a 12 volts battery, and then your digital multimeter has the position for 12 volts, you don't place it at 12 volts. There are some batteries which are charged up to 14.5 volts. Therefore, you will not get the correct readings. So what you do, you go to the next higher level. Assuming your digital multimeter has a 20 like mine, if you want to record DC, which is 12 volts, then you don't connect it. You don't place it at exactly 12 volts. You place it at 20 volts. So that if at all you get anything that is above 12 volts, your digital multimeter is not damaged. You're not using the digital multimeter for that day's purpose only. You require it for more days. Make sense? Great. Now, a good digital multimeter has to shut itself off when you're not using it, when it's not busy, so that it can save on the power. The power that is inside a digital multimeter is a battery which is rechargeable or a one-time use, 9 volts. Mine is rechargeable, so it has to shut itself down so that it doesn't consume the battery. Thank you for that sideshow. So we record. At this point, we have 237, but there's a problem here, very huge problem. If I place my tester at the line or the face, nothing is indicating on the tester. I almost thought the tester is faulty. If I place on the neutral, there you go. Don't know whether you can see it. Let me just have my camera closer. Come closer. Close. So let us see. Place it on the neutral. My goodness, look at that. At the neutral, we have voltage. At the face, we don't have anything. At the neutral bar, we have also, because the circuit is off, that is why. So now we switch it on. So when we switch it on, we have activated the neutral. When we place our tester right there, the tester is, it's lighting. Can we say lighting or turning on, or what is the correct language right there? Look at that. There's a problem. There's a huge problem. Why is the neutral having current flowing through it? What could be the problem? What could be the fault that is right there? What could have happened? Now that is where you find that an electrician is on site and they're telling you, you're asking them, can you place your tester on the line or the face? They say that power is not there. Do you have a digital multimeter? Because the digital multimeter will help you to understand that indeed there is a huge problem. Now, what are some of the things that may happen, bad things that may happen, if I may use that language? If at all, the neutral is the one that is carrying current. The neutral can carry current, but as a return path, so that it can complete the circuit. Remember, without the neutral, there is no complete circuit. So what can happen in that case is you may experience a scenario whereby the appliances in the home start to blow up. They're affected because that is a phenomenon that we refer to as a floating neutral. A floating neutral is basically a loose connection. So we need to fix that. So where could be the problem? Now, at the point of entry, let me just interchange my terminals here because that is where I messed up. But again, you may ask, John, we are not seeing what you are doing. We don't know what you're talking about. So in that case, my top boss, what usually happens, or what could be the problem with that, is that you'll find that, I don't know whether my meter has powered on. Not yet, not yet, not yet. Meter is still not working, right? Bring in the questions, my top boss. If you have questions, let me know how we can deal with that. Let me know what your questions are so that we can be able to discuss, we can be able to help each other. Not powering on still. Yeah, I'm going to have a rough one. Any question that you have, my top boss, let me know in the chats. Woo! Why is this doing this to me? Sure. All right, let me figure out how to easily fix it. It's just a few. So I'll simply take a cable here, just connect a cable that will be much help to this situation that John is in, or should we say on. This meter is supposed to give me a reading. Don't know whether it's visible from your end, and power is off just like that. What? Right. So we are going to use another means. So let me just connect power backup. I have a very good power backup here. This I was supplied by Lithium company. So I'm simply going to power it on Today there has been a lot of power outages, and I don't know what could be the problem. My meter is on, testing it at this point. We are good. So this is the good thing about having a power backup. Have a power backup right here. Good. Thank you so much for holding on as I was fixing my own problems. Thank you so much. It means a lot when I see that you are still here. Now I have corrected that by simply reversing the connection that was incoming here. That was very dangerous because this one is a digital multimeter. It could have damaged my meter. So I'm feeding this source from the socket. So I had reversed. So the neutral does not have a connection, but the phase is indicating. So let us just go and confirm that. If you'll be watching this video later, you can simply skip scenes and confirm that we actually fixed the problem. So on the phase or on the line, that is what we have. Can see it is on. Can you see on this the tester is on, isn't it? Check it here on. When you place on the neutral or even on the neutral, what? There's a huge problem, but because I'm using a power backup, probably that is the issue. I am not quite sure. So if you have that problem, it means that there is a return. But again, let me try and reverse on the input and see. They are going to have the same issue. Sorry about that. Someone was calling me. I don't know why people keep calling me when I'm live streaming. What could be the problem? Oh, still facing a challenge. I can't get my meter to power on. What? So now that being the problem, I think we can simply go on. All right. So if this is where you have an issue, the MCB for that lighting has tripped. What you simply need to do is before you lift it up, you first of all isolate that particular circuit. How? You switch off everything on that circuit. Let's say there are lights that are not working on that specific MCB, switch them off. Emmanuel Israel Obisio says, wow, thank you so much. And you say, this is great. I'm just joining in. Top boss, thank you so much and welcome. Machari Anjero says, you measured the voltage and the results showed 246. My question is, why the result yet you had interchanged the positive and negative? Because it is AC, multi-directional, alternating current, right? Alternating current. Alternating current has no issue even if it gives you those type of readings, okay? Or wasn't that the question, top boss? I hope it was. This is my backup right here. Power is still out. So if this MCB has tripped, you isolate the circuit, you simply switch. Maybe there are several bulbs, lights, you switch them off. And then you take the readings for continuity. Continuity will demonstrate whether there is a short circuit. Blink, good to see you. You're saying great class, top boss. Thank you so much for joining in. Blink, very proactive member here. So you place the indicator of the multimeter, and then you, after isolating the circuits, that is, you now record, you now take the, you see from the MCB, you have the outgoing to the specific circuits, okay? So you take a reading between the phase or the line and the neutral, right? So let us come up with a real life scenario. If at this point where you have that JB, assuming that there's a short circuit here, that can cause the MCB to trip, right? So if these live and neutral cables here are in contact with each other, it can cause the MCB to trip. And if you take the, in fact, later, can we do it practically? Can we intentionally short circuit live and phase? We will not turn it off for safety reasons. Do you allow me to do that? We'll not turn it on, but for us to record that continuity, it will be of very much help. What do you think, my top bosses? It's all about coming up with problems that didn't exist, but that can exist. So we can short circuit the phase and the neutral at the lighting point, and then we'll demonstrate that indeed that is the reason why an MCB can trip, okay? So if you allow me, of course, I'll be very careful not to switch the circuit breaker back on when the short circuit is still there until we sort it out with a multimeter. So do you give me a go-ahead, top bosses? If I get a go-ahead from you, definitely you're going to do that. So let me just record the voltage and see whether I have 214 from this side of and you interchange it. I'm using my power backup, and yes, so I was saying, if we short circuit the line and the neutral at this point, could be so that we can demonstrate how the MCB tripped, assuming that MCB is okay. And then after we sort that one out, we test and then turn the MCB on and then put the circuit, the lights on. So we go ahead and do it. Awesome. Machari Anjeru says, I got you, sir. Says, yes, let's do it. Blink says, yes. Jane Kanana David says, I'm watching from Botswana. Welcome. Thank you so much for joining in. And then Emmanuel, of course, says, Top Boss, I'm in love with your training. I would like to obtain a certificate from you. At the moment, you're not issuing any certificates. Thank you so much for your compliments. All right. So you have given me a green light to come up with a scenario. So I'm going to use a piece of a wire, just so that I can demonstrate that. Assuming we have this piece of wire, right? So we short circuit. Forgive my manners of stripping. That is not how to strip a cable using a pliers. But again, we are coming up with the problems. So my circuit is off. So in order for me to, come up with a problem, let me come up with a problem, isn't it? My circuit, remember, it's off. So to come up with a problem, I will short circuit the line and the neutral. So I simply lift one of the legs like that, insert it in. Oops, not getting anywhere. So I want to force them, the two of these cables in. I don't need to really have it go all the way, but it's there, right? And then for this other one, I want to do the same. Remember the MC. Don't try this at home if you are not sure about what is happening. The MCB is off. Insert it. All right. What do we expect? That is a short circuit. What do we expect at the consumer unit using a digital multimeter testing for continuity test? We expect continuity. Emmanuel says, I'm watching from Kaduna State, Nigeria. Nigeria is in the building. Oga, my brother. Welcome, my brother. Thank you, Oga, for tuning in. Smash the like button, Oga. Subscribe if you've not subscribed, and I really appreciate. Now, for other circuits, remember we said that circuits are controlled by MCBs. If at all there is a fault in that specific circuit, this MCB has tripped. We cannot attempt to turn it on because there is a problem. Now, it is still at the voltage setting. Now, if we take the readings for the voltage, you see, between the line and the neutral, we have 214. I'm using a different power backup. So if we take between the neutral or the neutral bus bar and the live or the line bus bar, we expect a reading which is 216. At the output of all these circuits, we expect a reading. If you place right there at the output of every MCB, we expect that there is a reading, as you can see what is happening on my digital multimeter. All of those MCBs have an output, 218, 218. Lastly, we have 0 for the MCB that has tripped, meaning that voltage is not going through. Now, because there is a problem and we don't want to put it on, we don't know whether this is this MCB is faulty. What we will do is to isolate that circuit. They'll say that we have started by isolating the respective lighting points by switching them on. Now, for me, what I will do is to completely isolate the MCB by simply unscrewing that line. So this is the line that is going to that particular line. Yes. Now, if I switch this MCB on and it sticks, it doesn't trip, it means that it is mechanically sound. Whether it is electrically sound depends on whether we will allow current to flow through it to a load. Now, at that particular point, we can measure the continuity of that MCB. Is it electrically sound? I will place the probes between the incoming and the outgoing of that MCB. I don't know whether you can hear that sound. Can you hear the sound? Am I audible, my top bosses? Can you hear me? Incredible. So we have isolated it and we can confirm that indeed it is electrically sound because of that beep. Now, what we need to do is to determine whether, see, if you shut it off, you place the probes, get a 1, infinity. If you turn it back on, there is a short circuit, meaning continuity. But we shall not reconnect this circuit back until we solve the problem. Now, continuity means a short circuit, and we do not expect a short circuit between this line and the neutral. What happens if we get it? Now we place the probe there, and on the neutral bar there is a problem. It means that if we reconnect it back and we switch the MCB on, it will still trip because the line and the neutral are short circuiting. See, if you place on the neutral one probe and you place the other probe on the line that is serving that specific circuit, there's an issue. You hear the sound? Now we have to get rid of that problem, and that is our assignment for today. Get rid of the problem so that you can be able to fix it. So the problem is we have identified that from what our makeshift problem is at this point here. So let us remove this short circuit by simply disconnecting our jumper wire that we had connected, that one, right? Short circuiting the line and the neutral. So we get it back like that. On this one, get it back. So there is no short circuiting between the neutral and the phase, or between the line and the neutral. And then we come back here again and we record between the output, assuming that we are still troubleshooting the problem and solving. All right. So using our probes, our multimeter, digital multimeter, it is on at the continuity test. We have already sorted that. Between the neutral and the line that is serving that circuit, there isn't a continuity. You can see on the meter, on the digital meter, multimeter, there is a 1, meaning infinity. We have corrected the fault. So now we need to connect back the cable. Very simple for us. We connect it and we screw. So this will be the first time that we'll be putting the line on, or the MCB on, when we have connected we have rectified the problem. We have used our digital multimeter to test for continuity. We confirmed that there was continuity, and so we are going to switch it back on and test for the presence of electricity in the light circuit, or in that circuit. So right, we can even go ahead and test when we have just connected. There's no continuity. So that means when we put it on and put on the light, it means that everything will be okay. So we switch it on. Now the moment of truth is here, my top boss. We switch on the bulb. And there we have it. I have solved the problem. In many cases, that is what will happen. Yeah. Thank you so much for the likes. I see you. I appreciate your feedback as well. My top boss from Nigeria, Emmanuel Israel, you have been here from the beginning. Thank you so much. So that is basically it, my top boss. You go circuit by circuit, assuming that the same problem happened with this. You see, you have a cooker unit here. It is supplied by this one. Yes, this MCB. Go to a customer, you find that there is an MCB that has tripped. In most cases, you'll find that a specific circuit has a problem. Only one MCB will have tripped. If at all that circuit is the one that has an issue, you now narrow down to that circuit. You ensure that you only solve it. So for instance, here you have a scenario whereby the cooker unit is on and the customer has said that my cooker is not working, it's not powering on. Those are some of the questions that you asked. Is it powering on? Is it only the plate, the hot plate, or even the baking section that is not working, or the oven, or both? What about the lighter? Is it referred to as the lighter, the one that that normally sparks to allow power to, to the gas to light up? You ask them, is it the hot plate? If they say it's the hot plate only, or one section of the cooker, then you know that that problem is localized in the cooker itself. All right, the electric cooker or the electric oven. The microwave is powering but is not heating food. That has got nothing to do with the circuit. All right, or I have this socket, a double socket that is here, for instance. One single socket amongst this double socket is not powering on. It has nothing to do with the circuit, because remember, that circuit has one line which is feeding this socket, unless it is a ring circuit. But if they say the cooker is not powering on, the cooker unit, this one, is not powering on, as you can see, is the shower head powering on? You put on that and it is powering on, then it means that there's a problem with that circuit. You go to the consumer unit as the electrician, you find that there is a breaker that has tripped. You do not lift that breaker or power it on before you find where the fault is. Isolate the cooker. If it is serving a kitchen where you have the microwave, isolate the microwave. Do not rush to power things on. You may power that MCB, probably the MCB was not faulty, and you are forcing it to turn on and it breaks completely. All right. So please ensure that you first of all narrow down where the problem is. For us, we had a makeshift problem at this point here. But how will you arrive at this point? You go on isolating every circuit. For instance, that was a lighting in the sitting room, or probably the security lights were not powering on. These security lights probably have 4 switches. I'm just assuming, or it is served by, from a photo cell. So all of them are not powering on. You narrow down to the photo cell, or you can take individual lights and start to powering them on, but that will be tedious. Okay, simply isolate the whole circuit from where the MCB has stripped. Get the continuity readings. Do the same for sockets. Do the same for heaters in that home. Narrow down, normalize narrowing down to the culprit. If as an electrician you suspect this unit, the instant shower head, the heater in that home is the one that has a problem, zero down to it. Simply isolate at this particular point, switch it off, get to the consumer unit, it is still off. Measure the output continuity between the line that is supplying that circuit with the neutral. That is usually the first suspect. If at all the continuity, there is continuity, or there is a, it is continuing, there's a beeping sound, there are zeros, and that is why a digital multimeter will really help. That is now when you know that there is a problem. In fact, if this switch is off, you have isolated this unit. At the consumer unit, the MCB is off, and you get a continuity. Then there has to be somewhere in that line between this switch and the consumer unit where there is a short circuit. Again, it could be localized in that switch. The phase and the neutral are continuing. It will send the signal back to the consumer unit, and that is where a multimeter comes in handy. My top boss, if you only work with this tester to go and troubleshoot, you'll have a very deep problem right there. How? Because you'll spend a lot of time for something that would have sorted out very fast using a digital multimeter, recording continuity tests. If there is an opening in the circuit and you probably have the MCB not tripping, but again, circuits are not powering. For instance, this switch here, you will definitely know that there is an open circuit. This normally happens when there is a loose connection, especially on the phase or the line. A loose connection on the neutral manifests itself in this manner. There is a return voltage or current that when you place that tester on the neutral, you will be able to experience it. All right. So that is it for today. That is our probably our part 1 troubleshooting. Next time probably we can be doing a lot of troubleshootings when it comes to solar, when it comes to zeroing in on the specific appliances in the home, the common appliances. Or let me ask you, put this question to you, my top boss. What is the next thing that you would like us to troubleshoot using a digital multimeter in a house electrical installation? And I will be glad to do it. Put it in the comments section. If, for instance, you'll be watching this video as a recorded version because it's going to live here on YouTube, top boss, I'll be glad to hear from you. What do you think should be our next process when it comes to troubleshooting using a digital multimeter? Thank you so much, my top bosses who have been here keeping me company in this live stream. Blink, thank you so much. I appreciate Emmanuel, of course. I also see Jane Kanana. Good to see you, Jane Kanana. It was an honor to have you. Macharia Njeru, thank you so much for keeping me company. Juma Yoweri, that was incredible. Zio CK says the reason is the live wire connection is wrong. That's why neutral wire becomes live. Really, maybe there's a loose connection. Aminuta. Brian Olango kept me company as well. Frank Edward Bahati, thank you so much for your time. It was such a great honor. Albert Domenyo, thank you so much, my top bosses. I really do appreciate your company, your feedback, your comments, your likes. It was such an honor. And for those who have already subscribed to my channel, and those who have subscribed during this live stream, and those who are going to subscribe after watching this video, my top bosses, I want to thank you so much. When it comes to electrical installations, troubleshooting using a multimeter, When it comes to wiring, when it comes to earthing, I will be guiding you, my top boss, on all of these important devices or all of these very important topics or subjects when it comes to electrical. Alpha Skimurgor, good to see you. Thank you so much for joining in. I really do appreciate. Until next time, my top boss, let us engaging on the comment section. This is the best way that we keep on interacting. If you want to follow me on other social media platforms, it is still Top Heights Electricals and Electricians, and I will really appreciate. If you want to privately reach out to me, it is John Gatehi, my top bosses. You can also send us an email, topheightselectricals@gmail.com, and I will definitely be glad to interact with you. You can also reach us on WhatsApp +254 711 34 34 12. Thank you so much, my top bosses. Have yourself a fantastic time. My name is John Gatehi, and this is Top Heights Electricals and Electricians. See you in the next one.